Good afternoon, everyone.
Good afternoon.
Welcome to Balluff's WebEx today on Total Weld Solutions Part 2 Applications. My name is Kevin Sardison. I'm Director of Field Sales for Balluff Canada, and the presenter today is going to be Greg Soden, once again, our Industry Manager. We have a couple of our salespeople here in the Mississauga office, and we're also joined by Jason Diaz, our Head of Quality and Technical Support Services. Thank you. So we'll get started now, and the WebEx should take about a half an hour to complete the WebEx, and then we'll have a question and answer period afterwards. So please hold your questions till the end.
Okay, good afternoon, everyone. It's Greg Soden here, your Industry Manager for Balluff Canada. Today's session we'll cover, as Kevin mentioned, our total weld solutions. We're going to focus a little bit more on applications and definitions that would reinforce the first part of our total weld solution. So getting started, we'll cover a few terms that you folks may hear when you're speaking with your customers. Arc welding is a process where fusion welding is done using electricity to generate heat. So the two base metals are heated to such a degree that they melt and fuse together. A spatter is a term where liquid metals are turned to droplets. These droplets will fuse to work surfaces such as sensors, to the cord sets. Spatter is also known as weld berries and spatter. So these will stick to the sensors and to the cables, and they'll actually cause either false activation and premature failure of the sensing devices. MIG welding, an arc weld process in which a bare wire electrodes inserted into the electrode. Inert gas is also fed through that weld gun. That process they refer to as GMAW or MIG welding, and this process of welding generates the greatest amount of weld spatter. We mentioned MIG welding generates the greatest amount of weld spatter. In order to combat that, Balluff have a whole plethora of sensors with PTFE coating on the sensors, which is also known as Teflon, and we also have a coating we refer to as W51, which is a new type of coating that is an inhibitor of weld spatter adhering to the sensor face. Balluff also have recently launched a series of new harsh duty cables, of which we have a silicone jacket cable, which we highly recommend to use in the weld environment. We also have Teflon coated steel prox mounts and aluminum bunker blocks. Prox mounts here, if you look at the bottom of your screen, there's a black device in which a sensor can be inserted. That's known as a prox mount. Our bunker block is this other larger machined aluminum piece to help protect the sensor. TIG welding, you may also hear that term from time to time. It also generates a high degree of weld spatter, but in this case, instead of a bare wire being fed through the electrode, they use a non-consumable tungsten electrode in its place. It has similar characteristics as MIG welding, and we recommend the same type of parts as in MIG welding to help combat that problem. So now we're going to cover some actual applications with customers. So we've taken images of customer pain points and challenges. In this case, our customer had a high sensor and cable failure rate, and that caused problems of increased planned and unplanned downtime. So here we notice that the sensor is exposed to physical damage, as well as the cabling here is also exposed to weld slag that would cause premature failure. You'll notice on the jacket, right here on the jacket, that is open, so the weld berries can ease in between the jacket and the cord set, settle inside and burn through. So our solution to the problem is to use a steel face inductive prox with PTFE coating and using a silicone jacket cable that we see here, right? There's no secondary coating on the cable required. If you look here in the bottom right-hand corner, there's a standard cord set that's inside a silicone tube. So this new cable set eliminates that extra need. We also recommend, if possible, for mounting the sensor is to use a PTFE coated steel prox mount in which the sensor can be installed in, and a bunker block. That's this device here. Not always are you going to have the luxury of real estate to use the bunker block or the prox mount. This is something to keep in mind in order to help reduce their rate of failure. In this case, the customer has also a high rate of sensor and cable failure. It is also increasing both planned and unplanned downtime. The sensor is realizing a lot of physical damage from weld slag, and how the sensor is mounted here, we're getting a lot of heat transferred, and it's not being allowed to cool, so you have a thermal runaway issue. You'll notice that here on the sensor cord set, it's open. Again, you have the opportunity of weld berries or weld slag easing in between the silicone jacket and burning the PUR PVC type cabling. Again, to combat this, and to use steel face PTFE. Again, to combat this problem, we recommend again to use our harsh duty cable, the silicone jacket cable. Keep in mind, when our customers use the silicone jacket material, that secondary protective silicone. Next slide is of a flat packs proximity sensor mounted in tooling and weld. In this case, we can see some pitting damage due to weld berries and weld slags on the face of the proximity sensor. The other thing that we can notice is that the cord set is totally unprotected, and it's also being exposed to the weld slag that would settle on top of that pigtail, cause burn through and short out the sensor. So to combat that, we would recommend that we look at our new flat pack proximity sensor. It's a stainless steel proximity sensor with a stainless steel face. The black coating is what we refer to as our W51 coating. It's a combination of a ceramic and Teflon type coating that we've patented and developed. With this particular sensor, what Balluff has done is installed a silicone tubing around this proximity sensor pigtail. That silicone tubing will offer an advanced layer of protection against weld slag. The other thing to be aware is that in the connector head, that is where we're locating the LED lighting. So the LED is out of harm's way. It removes the weak point that would normally be positioned on the proximity sensor. On this tooling, there is high rate of damage due to heat and physical damage. In this case, the customer is using a 12 millimeter prox that has a 2 millimeter sensing range. So our solution was, again, to use a Balluff proximity sensor, the steel face PTFE, to help reduce the incursion of the weld berries on the sensor face. And with our proximity sensor, we have a 12 millimeter sensing distance. So that added sensing distance would help remove the sensor from being struck. It has a little bit more forgiveness. With having the workpiece removed, it would provide less heat stress to the proximity sensor. Of course, we've been preaching about using our steel-coated prox mounts. That's highly recommended if you have the luxury of the room to install that. And of course, to use our silicone jacket cord set. I can't stress the use of our silicone jacket cord sets enough. In this case, we have a proximity sensor that's failing due to weld slag. It also has some stress due to heat. The sensor, in this case, the mounting has become loose, and when that becomes loose, then you're getting erratic or unstable signal back to your primary control. If we look at the back of the sensor, there's no protection added to the proximity sensor. That allows a point of weld slag of accumulating and a burn-through opportunity to occur on the cord set. To help eliminate this problem of physical damage, we were suggesting the replacement of a 12 millimeter unshielded prox with an 18 millimeter PTFE steel phase sensor, and to add a prox mount that would ensure that the sensor would not be overextended and receiving physical damage from the workpiece, and would also provide an added layer of thermal protection. Of course, the cord set, again, we want to recommend the use of our silicone jacket cord set. In this case, it may not be possible to put the bunker block, but if and when you can use that accessory, that will certainly help reduce physical damage and reduce the thermal impact on the prox. In this application, we have examples of where they're using a standard proximity sensor with a pigtail and a quick connect prox. They're being laden with weld berries, weld slag on both the proximity sensor and on the cord sets. This will cause premature failure of the sensor or premature triggering of the proximity sensor. So our solution, again, is to have our steel face PTFE coated proximity sensors installed to repel the weld berries and the weld slag, to use our prox mounts, and to use our silicone jacket cord set solution. Now, with regard to cylinder sensors, here a customer has problems with their cylinder sensors. In this case, they've had the cylinder sensors would migrate because of a loosening of the set screw. They also had burn-through issues here in these points. Here you can see they've tried to protect the cabling, but there's still open areas of the cords of the sensor. To replace that, Balluff has developed new cylinder sensors with a silicone tubing that's built right in on the sensors. Here you've got open points in which the weld slag can slide down and burn through on the cord set, on the cabling. That would be eliminated in its entirety with our new cylinder sensors with the built-in silicone tubing. This is a new product that we're not aware of any of our competitors of having such a product, so that would be another big differentiator. On these Balluff sensors, you'll also note that we have a improved set screw holding system that will not be susceptible for that set screw to come loose. In this instance, we have a through beam optic sensor, and the lens of that sensor would get dirty, and when it would get dirty, there could be an escape of the drill bit and tap from being correctly detected in place. To combat that, we would continue to use that sensor, but we would want the customer to have code written in the PLC to ensure that there's a making and breaking on every cycle, and to install a separate sensor to compare the position of the actuator to the status of the sensor. Also on that secondary sensor, we would suggest to have a secondary output to notify the operator when the lens is dirty, so that you have a proactive means of ensuring that the sensors are working correctly with its logic. Using a diffuse background suppression sensor would be a good candidate in this case. Here we have the use of our linear transducers. What we're doing here in this case is we want to ensure that a weld nut is in its proper position. If the weld nut is upside down, we would be able to properly detect that differential with the use of our BTL linear transducer and our BDD digital display, which would be connected to the primary control of that pedestal welder. By having a system like this, the customer is able to ensure a fast setup. If they're running different parts, then they can configure the system to be compatible with each different part, and it would certainly eliminate incorrect parts being welded, and that would reinforce the customer's error-proofing initiative. In this case, we're showing the use of RFID inside a weld cell on tooling. The customer before they implemented this RFID solution, everything was manual in terms of setup. It took longer, and it also introduced a probability of error with the wrong tool being installed for the process that they wanted to run. And that could cause either damage to the tooling and or to the product that they're manufacturing. So by installing a Balluff RFID solution where they affix a read-write head onto the base of the weld fixture, and then the tooling that would come in and out, on the bottom of that was an RFID tag. So now when the tooling was put into place, the RFID reader would simply read the tooling. That would tell the programmable logic controller on what parameters to set up for that specific feature. So now we have 100% assurance that it's properly set up for that right process and zero downtime due to that type of error. And that's it, everyone. Hopefully that'll give you some ideas on how to install our solutions into a weld environment.